Alright, let's do question number 2. Trace the different conic sections when the distance of the focus from the directrix is 80 mm and eccentricity is equal to 179 and do 1 in the curves. Alright, let's start with the basics. Eccentricity is the distance of a point from the focus by distance of a point from the directrix. Now, for a circle, eccentricity is 0. For a parabola, it's 1. For an ellipse, it's greater than 0 and less than 1. And for a hyperbola, it's greater than 1. I've written it down over here as well. Now let's start with this one, 7 by 9. First off, just draw basic y-axis and an x-axis. After that, the question has said 80 millimeters, but if we take 80 millimeters, it's going to take a lot of space, so we're going to reduce it down to 20 millimeters. So the scale is going to be 1:4. So 20 millimeters takes up 80 millimeters. So 20 millimeters is where the focus is. Now, the eccentricity that's been given to us is 7 by 9. So what this means is a point on the ellipse is going to be 7 units of distance away from the focus and 9 units of distance away from the directrix. What you can do is 7 plus 9 is equals to 16. Now divide the length between the origin and F into 16 equal parts, and then here's the point. This point is 9 units away from the directrix and 7 units away from the focus. So this is a point on the ellipse and it's a vertex, right? So what you want to do is draw a line perpendicular to the x-axis over here, and this is going to be exactly 9 units away from the directrix at this point. Now use a compass, because we've already taken 7 units over here, use a compass and just cut an arc over here. Okay, so from here to here, and this is going to be 9 units away from the directrix and 7 units away from the focus. Okay, oh wait, sorry. So this is going to be 9 units and this is going to be 7 units. Now the ratio is going to stay the same if you draw a line over here. So at all points over here, this is going to be 9 units and this is going to be 7 units down. 9 units, 7 units. The point here is 9 units from the directrix and 7 units from the focus. Sorry, we could have simply just taken 7 centimeters over here and 9 centimeters over here to get 9 centimeters over here and 7 centimeters over here to get the same result. But because we wanted to find the vertex over here, we just took this as the reference. After that, what you're going to do is take this point, right, and use a protractor and mark a point for 45 degrees and join the lines, and it's going to intersect at a point on this guiding line. Now drop it straight down to the x-axis, and that's going to be where the end point of the ellipse is going to be. I don't know why it's the way it is, but it is. Now next we're going to make markings for the ellipse. Suppose this, so first of all, you've got to divide the distance between the vertices into equal divisions. And it doesn't even have to be equal, but just for it to look good, make sure that it's an equal division or like close to equal, because the distance between them doesn't really matter. It's just for a reference to draw those. So you can take 0.5 centimeters or even 2 millimeters if you want that super accurate drawing. So do your thing, but I've taken it at, it's the distance between each division is 0.5 centimeters. So draw the lines, right? And how you're going to do the markings for the ellipse is for this line, from the point to the point on the guiding line, you take the distance on the compass, put the compass's pin on the focus, and then make the markings here and here. Similarly, for this line, it's going to be over here, right? So you put this on the focus and you cut it across over here, and you do that to get the ellipse. Pretty basic, right? Now similarly and the way you write it is, write the name of the curve, write the eccentricity 719, and scale 1:4. Always write the scale at the bottom, okay? We did the similar thing for the parabola. Parabola, eccentricity 1, scale 1. Now this is also 20 millimeters in actuality, but we write it as 80 millimeters. But in actuality, it is 20 millimeters when we're actually measuring it. Remember the scale 1:4. Oh, almost forgot. I have to show you how to draw the tangent. So to draw a tangent at any point on the ellipse, just join the point to the focus and draw perpendicular to the directrix. So make sure that it's perpendicular, right? And join these 2 points, focus and the point. Make a perpendicular to that point, and at the point where it joins the directrix, just join the point on the directrix with the actual point, and that gives you the tangent. Now similarly, the eccentricity is 1, or you can also write 1 as 1 by 1. So add 1 plus 1 gives us 2. Okay, so we need 2 divisions between the focus. Now because the focus is in actuality 20 millimeters, which is 2 centimeters away from the directrix, you can simply make a marking at 1 centimeter and draw perpendicular. And just to show you how it's done properly, you take your compass over here, put it on the focus, and it's 1 centimeter, and you make a marking on this line, and this is going to give you the point which you can join with the origin to give you the guiding line. Or you could simply just take 1 centimeter and 1 centimeter, but just to be sure, just do both ways. This is the guiding line. Then you draw the divisions, right? And then you, for this line, it's going to be this. Focus is over here. Boom, boom. Do the markings and all that. You know how to do it. After you've drawn the parabola, let's suppose we want to take a tangent at this point Q. Join the focus and the point. Draw perpendicular to the line. And then the point which touches the directrix, just join those and extend it. And that's going to give you the tangent for the point on the parabola. That's how you do question number 2.